What's up, everyone? Welcome back. Patrick here, moving on to another question dealing with quadratic. So we have to create a quadratic in standard form for each of these different scenarios here, and then we have to verify the x-intercepts in each of these with the quadratic formula. So the first scenario, we just have to create a quadratic that's going to have two x-intercepts. So we have flexibility on which x-intercepts we choose. Let's say I choose -1, +3. So the quadratic would maybe look something like this. And so creating an equation here, we'll have y equals, what would be the factor for an x-intercept of -1? It would be x plus 1. For an x-intercept of +3, it would be x minus 3. Now they want this quadratic in standard form, that's in factored form right now. So let's expand it. By the way, I'm just going to keep the a value here as +1, but you could put whatever you want here. This could be also opening down if you want to put this a value as negative. Again, I'm going to keep it positive. I'm just going to keep it +1. It's going to make our expanding a little bit easier. So we'd end up with what? X squared, -3x plus x would give us -2x minus 3. There's our quadratic right there. In standard form, that has two x-intercepts. And then they're asking, we have to verify the x-intercepts with the quadratic formula. So how would we find the x-intercepts of this kind of quadratic in standard form? We'd plug in 0 for y. And then notice we have a quadratic equation to solve where the a value is 1, the b value is -2, the c value is -3. And then plugging those into the quadratic formula, x equals -b. Let's write out, actually, I'll just go straight into the formula. You guys should be fairly comfortable in knowing it by now. So we'd have that over 2a, which is 2 times 1. So we'd have 2 plus or minus, this would be 4. -2 squared is 4. -4 times 1 times -3 would give us +12 over 2. 2 plus or minus √16. Sorry, why did I put a 12 here? This is 2, right? 2 times 1 is 2. And then over 2. So that would be 2 plus or minus √16 is 4 over 2. So the two different solutions would either be 2 plus 4 over 2 or 2 minus 4 over 2, which would give us 6 over 2, which would give us 3, or -2 over 2, which would give us -1. And notice those are the two x-intercepts that we started with. So we verified it with the quadratic formula. Moving on to part B, let's say that there is one x-intercept. Now, if there's one x-intercept, what does that mean? That means that the one x-intercept is also going to be the vertex of the quadratic. And when it factors, it's always going to factor as a perfect square trinomial, so there's only going to be one factor. So you could pick any you want. I'll pick, let's pick a value of 2 here. So if I have a quadratic like this, what would the factor for this be? X minus 2, but it'd be squared because there would only be that one factor, right? This always factors into a perfect square trinomial if you're dealing with a quadratic with one x-intercept, and that x-intercept would be the vertex. You could also put whatever a value you want here, any number. You could also put a negative. This could be opening down if you want. Again, I'm just going to keep it as +1 just to keep things simple. So if we expand this, x squared minus 4x plus 4. That's the quadratic in standard form. That's this quadratic right here. Now, if we wanted to get the number or verify the number of x-intercepts, we can do that. A value would be 1, the b value would be -4, the c value would be +4. So we know x for the quadratic formula would be -b, so -4 plus or minus b squared minus 4 times the a value of 1 times the c value of 4. All over 2 times 1, which would give us 4, plus or minus, this would be 16 minus 16 over 2. And I mentioned this in videos before. You should get a 0 under the square root if there's only going to be one root to the equation you're solving for, or one solution. So notice that we do get that 16 minus 16, so this whole thing goes to 0. So we're just left with 4 over 2, which gives us that x value of 2, as expected, that x-intercept right there. All right, so we verified it. We first came up with the quadratic with 1 x-intercept of 2 over here. Then we verified finding the x-intercepts with the quadratic formula, and we only got one value of 2. Moving on to part C, this one is saying that there are going to be 0 x-intercepts. So if there's 0 x-intercepts, two different ways that could happen. Either the vertex has to be above the x-axis, so like right here, let's say, and the quadratic has to be opening up, or the vertex has to be below the x-axis, whether here or here, and then the quadratic has to be opening down. So either scenario works. I'm going to go, let's switch it up. So let's go over here. Let's say this vertex is at -3 and -1. And then it has to open down. So because we're dealing with the, sorry, let me draw this one more time. -3, -1, this is the vertex. It's going to be opening down. Now, because we're dealing with a vertex, I would recommend putting it in vertex form first. Remember, vertex form is this, where that h and k value is going to be the vertex. So the h value is the x value of the vertex, which is -3 in this case. So this would be x minus -3, which would be x plus 3 squared. And then the k value is -1. We got a -1 like that. But then we need an a value over here, and we got to make sure that this a value is going to be negative, because since the vertex is below the x-axis, we need the quadratic opening down so it doesn't pass the x-axis, because we're trying to have 0 x-intercepts. So you could pick anything, -0.5, -1, -2, -100, whatever you want. As long as it's negative, I'm just going to go again with a simple -1 in front. So if we expand this, this would, x plus 3 times x plus 3 would be that. And we have -1, distribute the negative inside the bracket. And so we'd have -x squared minus 6x minus 10, like that. Okay, so this and that, those are both the exact same quadratics. Okay, so we have our quadratic in standard form, and that has 0 x-intercepts. Now let's confirm that it has 0 x-intercepts, so we would plug in 0 for y to find the x-intercepts. A is -1, B is -6, C is -10, and then let's plug these into the quadratic formula and see what happens. 4 times the a value of -1 times the c value -10, all over 2 times the a value -1, like that. So we'd end up with 6 plus or minus, this would be 36. -4 times -1 is +4 times -10 would give us -40. And if you notice what happens, we get a negative under the square root. And I mentioned this, sorry, I don't know why I put -20, this is -2. As I mentioned, whenever you get a negative under the square root, you can't go any further. You can't take the square root of a negative, so there are no solutions to this. There are no solutions to this quadratic equation, meaning that there's no x-intercepts for that quadratic, as expected, right? And we verified it with the quadratic formula by getting a negative for the discriminant, which is that b squared minus 4ac value. You can't square root a negative. Hence, there's no solutions to that equation. Then in part D, they're saying there's 2 x-intercepts and it opens down. So again, let's draw something. Let's go, you know what, let's do it a little unique now. So let's get an x-intercept of 0. Let's have it go through the origin. And then let's put an x-intercept here, -4. So let's say something like this. So what would be the factors here? Well, a factor of 0 would have, an x-intercept of 0 would just have a factor of x. An x-intercept of -4 would have a factor of x plus 4. But this has to open down, right? So this a value in front has to be negative. We could choose what we want. I'll choose, let's say, a -2, like that. So we'd have y equals -2x, x plus 4, which would be in standard form -2x squared minus 8x, like that. Okay, so this quadratic here, if you took it, if you graphed it in Desmos, you'd end up with a quadratic like this. 2x intercepts 0 and -4. Now let's confirm that or verify it with the quadratic formula, plugging 0 for y to make it an equation. A is -2, b is -8, c in this case is 0, right? There's no c value, so it's just 0 over there. So we'd have x equals -b. Again, let's go straight into the formula. -b, so -8 plus or minus b squared, so -8 squared, minus 4 times the a value -2 times the c value 0, all over 2 times the a value -2, like that. So this would be 8 plus or minus. This -4 times -2 times 0 would just go to 0. -8 to the power 2 would give us 64 over -4. So we'd have 8 plus or minus square root of 64 is 8 over -4, like that. So notice there's two solutions, either 8 plus 8 over -4 or 8 minus 8 over -4. And notice, what do we get? Well, we get 16 over -4 here, which would give us -4. Or we get 0 over -4, which would give us 0. Exactly as we expected, because we started with this diagram, took those x-intercepts, made the factors, added a -a value, put it in standard form, and then from that standard form, we solved for when y is going to be 0, right, for those x-intercepts. And notice that we got the same x-intercepts that we started with. Okay, so we verified it with the quadratic formula. Part E, they're saying there's one x-intercept and it's going to have a y-intercept of -5. So in this particular case, let's see how this would look. It has to go through here, 0, -5. And then there's only one x-intercept, meaning that the vertex is going to be on the x-axis, right? Same thing as part B. It's just now we have to have more details. So the vertex can be on this side, on this side. I'm going to put the vertex here. So let's put the vertex at, I'm not sure. Let's put it at -10 and 0, like this. So this, we'd have this, like that. And so because we have the vertex here, and it's just one x-intercept, then we know that the quadratic is going to have a factor of x plus 10 squared. Now, there's going to be some kind of a value right there, right? Because it has to go through this y-intercept. So then we could take this and plug it in here. So we'd have -5 equals a 0 plus 10 squared. This would be 100. So the a value would be -5 over 100, which would give us -1 over 20, like that. Okay, so this here would be -1 over 20. Give me a sec here. Yes, -1 over 20, like that. Okay, so this quadratic here, it's going to have one x-intercept at -10. It's also going to have a y-intercept of -5. If you plug in 0 for x, you'd get a y value of -5. But again, they want it in standard form, so we're actually going to have to expand this. So we'll have y equals -1 over 20 x squared plus 20x plus 100. Then distribute this -1 over 20, so we'd have -1 over 20 x squared. -1 over 20 times 20 would give us -x. -1 over 20 times 100 would give us -5, like that. So there we have a quadratic in standard form. And then to verify with the quadratic formula, notice that we're going to have a fraction here. So what I would recommend is multiplying everything by 20 to get rid of that fraction. We've done videos like that before, where if we have a quadratic equation with fractions, multiply everything by 20, so we'd have 0, negative x squared. 20 times negative x would give us negative 20x. 20 times negative 5 would give us negative 100. Okay, so we'll have an a value of negative 1, a b value of negative 20, and then a c value of negative 100. So let's see if we get that one x-intercept of negative 10 with the quadratic formula as we're expecting to. So let's put a little room here. X would be negative b, so negative 20 plus or minus negative 20 squared minus 4 times the a value negative 1 times the c value of negative 100 all over 2 times the a value negative 1. 20 plus or minus 400. Negative 4 times negative 1 is positive 4 times negative 100 would give us negative 400. And as expected, this would be negative 2. As expected, under the square root should be a 0 if we're only going to have one x-intercept. Okay, we saw that as well in part B. So what do we get? This would be 0, so we'd end up with 20 over negative 2, which would give us negative 10, like that. As expected, that one x-intercept that we started with. And then finally part F, they're saying there's 0 x-intercepts, it opens up and it passes through the point 1 and 6. So this one, it's passing through the point 1 and 6, so that's going to be like here. It has to open up, so the vertex has to be below this point. So let's put the vertex like over here. Let's say this point is going to be, I don't know, let's say it's 2 and 1. So that's the coordinates of the vertex. We got 2 and 1, and it's going through 1 and 6. So this quadratic is looking like this. Notice it's not crossing that x-axis. So it has 0 x-intercepts as required. It opens up, and it's passing through 1 and 6. You could have put this vertex anywhere over here below the 1 and 6. Could have been on this side as well. I'm just going to keep it here. So because we have the vertex, let's put it in vertex form. X minus 2 squared plus 1. And then let's plug in 1 and 6 for the x and y to solve for the a value. So we'll plug in 6 for y, a. Then we'll have 1 minus 2 squared plus 1. Bring the 1 over. 6 minus 1 is 5. Negative 1 squared. Sorry, the a value is still in front. 1, 5. So the a value is just 5. Right? Let me just double check. Brought the 1 over. 6 minus 1 is 5. Negative 1 squared. Positive 1 times the a is just 5. So we could plug that back right here. All right, if you need to go through this one more time, you'd have to go back to the vertex form videos of where we're given quadratics with a vertex and another point, and we're solving for that a value. That's exactly what I'm doing here. I'm assuming that you've watched all of those videos and you're fairly comfortable with this now. So that's in vertex form, but we need it in standard form, so we have to expand all this. Like that. So we'd have 5x squared minus 20x plus 21. That would be the standard form. And to verify that it has no x-intercepts, we take this, create an equation. A is 5, B is negative 20, C is 21. And if there's going to be no x-intercepts or no solutions to this quadratic equation, remember that square root, that discriminant, is going to have to be negative. So let's see if we do indeed get a negative value. We'll have x equals negative b, so negative 20 plus or minus b squared, negative 20 squared minus 4 times the a value of 5 times the c value of 21, all over 2 times that a value of 5, so this would be 20, plus or minus, this would be 400 minus 20 times 21 would give us 420. So as expected, 400 minus 420, notice we end up with negative 20 in the square root. And so there's no solutions. We can't go any further. We can't solve this because you can't take the square root of a negative value. Right? So from there, we showed that this quadratic here, I actually erased the standard form. It had the plus 21 at the end. which is this quadratic here, we showed that it indeed has 0 x-intercept.